Out on an isolated inland lake, the hours around midnight under a bright full moon can feel completely dead quiet. But beneath the surface, apex predators like muskie and largemouth bass enter states of hyper-aggressive feeding. The entire ecosystem is rushing into a sudden, intense burst of activity. For decades, hunters and anglers have relied on something called the Solunar theory to predict these exact frenzies. They use printed tables that map major and minor feeding periods directly to the phases of the moon. The core assumption behind these charts is gravitational. The idea is that the moon's pull creates tiny localized tides and shifts in water pressure, and that those physical changes act like a starting gun for the fish to hunt. The feeding frenzy is a well-documented biological reality. The fish really are striking, but the gravitational explanation is completely false. To figure out what's actually triggering the lake, we have to completely ignore gravity and look straight into the cold, dark eyes of these nocturnal predators. Astrophysicists call this the M2 Tidal Constituent. The moon's uneven pull stretches the Earth's oceans into two large bulges. But to build this 12-hour wave, water needs massive room to redistribute. Inland lake basins are simply too short for that wave to accumulate. Even in Lake Baikal, the deepest, most voluminous freshwater lake on planet Earth, precision instruments measure the primary lunar tide at roughly 8 millimeters. That is less than the width of a AAA battery. Scale that math down to a typical fishing lake, and the lunar gravity argument falls apart. A standard fiberglass bass boat floating on the surface exerts a stronger direct gravitational pull on the water immediately beneath its hull than the moon does from 238,000 miles away. A force measured in fractions of a millimeter is entirely incapable of orchestrating a violent, lake-wide feeding frenzy. Lunar freshwater tides are a mathematical ghost. The moon is projecting a very real physical signal into the lake. It arrives as electromagnetic radiation in the form of moonlight. This animated cross-section shows light penetrating the water column. Its decay is calculated by the vertical extinction coefficient. In clear, oligotrophic lakes, predators use moonlight at 20-meter depths. In turbid systems, this visual window compresses to the top 3 feet. By altering the nocturnal environment, the moon carves highly specific visual corridors in the dark. That sudden influx of photons dictates the lake's biological clock. To weaponize those incredibly scarce photons in the dead of night, apex predators have evolved highly specialized ocular anatomy to see in the dark. In dim light vision, nocturnal retinas are packed with rod cells. Through neural summation, signals from dozens of rods pool into one amplified pathway. If a photon misses, a biological mirror called the tapetum lucidum bounces it back, effectively doubling the eye's visual capacity. When the full moon clears the horizon, predatory predators suddenly possess a massive tactical advantage. They can see prey from distances that were impossible an hour earlier, creating an ecosystem-wide lunar light trap. Prey species are forced into a defensive posture called lunaphobia. Baitfish and zooplankton suppress their natural movements, diving into deeper shadows and abandoning their normal feeding grounds to avoid detection. Moonlight flips the entire trophic hierarchy of the lake. The predator's evolved ocular anatomy turns a slight increase in ambient light into a lethal tool. The old Solunar tables and the anglers who swore by them correctly documented the exact hours the fish would strike. Their observations were entirely accurate. But the mechanics driving those strikes have nothing to do with gravity. The biological trigger is strictly optical. The feeding windows in a landlocked body of water are perfectly synchronized with celestial mechanics. Life and death in the silent depths of an inland lake are decided by specialized retinas, harvesting the reflected light of a dead rock floating 238,000 miles away.